Okay, lesson 5.2. All right, so this is going to look at quadrilaterals from the other direction. Instead of stating something about a quadrilateral, we are going to be able to prove something prove that a quadrilateral is a specific quadrilateral, in this case, a parallelogram, based upon the information given. So I'm going to give you a quadrilateral, and I will tell you something about it, and by the end of the class, you'll be able to prove that it is, in fact, a parallelogram, one of the six types of quadrilaterals. All right, here we go. So last class we talked about the parallelogram, and there were five main things about parallelogram. By the definition, a parallelogram is a four-sided shape, so a quadrilateral, where the opposite sides are parallel. So both sets of opposite sides are parallel. We name parallelograms using the parallelogram symbol. We pick a vertex A, B, C, or D, and we either go clockwise or counterclockwise. There are five basic properties. So the definitional property, the second one, we proved that opposite sides are congruent. We also proved that opposite angles are congruent as well too. The last two, first is the diagonals bisect each other. I need a different one. It's getting a little crowded there. And then the very last one is that consecutive angles are supplementary. Now, remember, the consecutive angles are supplementary is not an actual theorem in the book, but it is something that we got so I call that the theorem without a theorem. Remember, this is the one where if you have two parallel lines cut by a transversal, then cut by a transversal, then any two sides, why is this not drawing? Then any two sides, or two angles, sorry, then any two angles that are next to each other will be in fact supplementary. Okay, so those five things. All right, today we do a switch on this, and once again, I'm going to give you a quadrilateral. I'm going to give you some information, and your job is to prove that it is in fact a parallelogram. All right, so I'm going to hand you quadrilateral. I will tell you something about either the sides or the angles or a combination, or maybe something about the bisectors, and you will be able to prove that it is a parallelogram. So it turns out there are five ways to do this. And I don't know why that five keeps popping up all the time, but it does. So don't panic. There's just five of them. I would absolutely put a big box in your book of truth and state ways to show a quadrilateral is a parallelogram, and then list the five ways. All right. All right. So the first way is the easy way, or I should say the most obvious way, which is if we can show that both opposite sides are in fact parallel, then it is a parallelogram. So I'm going to hand you the quadrilateral. You're going to prove it's a parallelogram. There are five ways. The first way, the one I just stated, if you can show that opposite sides are parallel, it's a parallelogram. All right, so write that down. The first one in your little box, five ways to prove a quadrilateral is a parallelogram. Show that opposite sides are parallel. There'll be five of these eventually. Okay, second way. We got to prove this one. And why didn't we prove the other one? Because that was just based upon the definition. So this will be different thing. So let's see. I have a quadrilateral, and it looks like that I have opposite sides are congruent. Is that in fact a parallelogram? Let's see. All right, so it starts off like this. Maybe some of you are already yelling at the screen. You can see what we're going to do here. How about we make, instead of a quadrilateral, we make two triangles. So let's cut this parallelogram. All right. Let's cut this. Oh, let me explain what I'm doing right here. Well, since we only have one way to show that a quadrilateral is a parallelogram so far, show that opposite sides are parallel, then that's how it's going to end. So it's going to end with me saying that the left and the right are parallel and the top and bottom are parallel. That's how it's going to end. To get there, I'm going to, in fact, make two triangles. So I'm going to construct EG. So I'm sorry, construct EG. So it's an auxiliary line EG. And notice immediately, hopefully you see this, we have reflexive properties, so those two triangles are in fact congruent. All right, so if those two triangles are congruent, right, by SSS, notice I also labeled angles 1, 2, 3, and 4. Well, if those two triangles are congruent, then let's see, angles 1 and 4 would be congruent, and angles 2 and 3 would be congruent. That's just CPCTC. And if we notice, I'll draw this one for you. Let's do this in blue. If we notice this, then therefore, if I have two parallel line or two lines cut by a transversal, and I can show that this angle right here is congruent to this angle, that only occurs if the two lines are in fact parallel. And that would also work for if this line and this line were cut by a transversal. And if I could show that this angle and this angle were congruent, then that only would occur when the two lines are parallel. And in fact, I have done both of those. So therefore, those two lines, left and right and top and bottom, must be parallel. That's just the converse of the alternate interior angles theorem. Cool. All right, so what did we just prove? We proved that if opposite sides are congruent, then in fact you have a parallelogram. So this would be the basically the converse to 5.1. So you do need to show that both pairs of opposite sides are congruent in order to prove that it's a parallelogram. All right, so now we have two of these. Thing number one, if we can show that opposite sides are parallel, or if we can show that opposite sides are congruent, either one of those proves that your quadrilateral is a parallelogram. Three more ways, three more ways. All right, third way. This one's a little different. All right. You're going to prove this one for homework. So let's start off with a quadrilateral, and I'm going to start off with one pair of sides, either left and right or top and bottom, are both parallel and congruent. And notice I can't immediately state that these are in fact a parallelogram. I don't have both sets of opposite sides. I only have one set. So, well, you're going to prove this. I'll give you a hint, make two triangles, and it'll become apparent from there. So write this one down. This is theorem 5.5, and this is our third way of proving that a quadrilateral is a parallelogram if one pair of opposite sides are both, it's got to be both, parallel and congruent, then it's a quadrilateral. I'm sorry, then it's a parallelogram. And once again, I said the hint for homework is make an auxiliary line, make two triangles. Okay, so there's a three. We got two left, two left, two left. All right, fourth way. Once again, you approve this for homework. This is the converse to 5.2 that states if opposite angles of a quadrilateral are congruent, then it is in fact a parallelogram. Same hint for this one. Make two triangles. Okay, looks like we only have one left to go. One left to go. Let's see, which one will this one be? The fifth way. This is the last one to prove for homework. So if the diagonals do in fact bisect each other, then you have a parallelogram. This is the converse to 5.3. All right, so those wrap up the five ways. This is what your big box should look like in your book of truth. Hey, if they ask you to prove that something is a parallelogram, you have five different ways of doing it. Just depends upon what information they give you, which one of those five you want to use. All right, so we've proven two of those. You have those three tonight for homework. Those are the five basically right here. Once again, so those three black ones. And once again, my hint was to make triangles. All right. I'll just give you a little example here of what it looks like. So let's see. Are these parallelograms or not? Let's see. On the first one, let's see, we have opposite sides are in fact congruent. So if opposite sides are congruent, that's theorem 5.4. So one is in fact a parallelogram. How about number two? Number two, I have one set of opposite sides, both congruent, 9 and 9, and both parallel. So if that's number three, show that one pair of opposite sides are both parallel and congruent. All right, number three. Three's the first tricky one. First tricky one. Hopefully you're yelling at the screen at this point right now. Let's see. So we have a bunch of triangles. Can we show that those triangles are in fact congruent? Hmm. Well, that was a bit more challenging right there. So we can certainly see that one diagonal is bisected. Is the second one bisected? So in fact, we would have to show that some those triangles are congruent. I know you're yelling vertical angles right now. Does that actually prove that they are in fact congruent? That one's going to need a little bit of thought to it. Okay. So there's just a couple examples of what homework will look like. All right. So just remember for the proofs in class, we proved two of them. You're going to have to prove the last three in class. So that will do it for today's class, and I will see you in the next class.